Algebra Lesson 9-2, Multiplying and Factoring. The rules for multiplying monomials and the distributive property can be used to multiply a monomial and a polynomial. Remember, you have to remember all those properties of exponents as well. So let's simplify each of these products here. If we're trying to multiply a monomial times a polynomial, you're basically going to distribute all the way through the polynomial. So we're going to take this 4b and we're going to multiply it by everything inside the parentheses. So we're going to multiply the 4b times the 5b squared, the 4b times the b, and the 4b times the 6. If this will help you, write it out. 4b is going to be multiplied by 5b squared, and then you're going to add, the 4b is going to be multiplied by the b, and you're going to add again, and the 4b is going to be multiplied by the 6. So 4 times 5 is 20. B to the first times b to the second is b to the third. Remember, same base, you're going to add the exponents, hence why we have to remember what we learned in chapter 8. Plus 4b times b times b is b squared, so 4b to the second power. Here we have the 4 multiplies by the 6, so that becomes 24. There are no other variables, so it's 24b. So when we multiply this out, we get 20b to the third plus 4b squared plus 24b. Okay, if we look at this problem number 2 here, which I'll do in a different color so it can be easily seen, I'm going to take this negative 7h and I'm going to multiply it by 3h squared. And I'm going to take my negative 7h, I'm going to multiply it by negative 8h, because there's a negative sign right there, sign goes with number. And then I'm going to take my negative 7h, and I'm going to multiply my negative 7h by a negative 1. If you want to, you can make this plus a minus right in there. So negative 7 times 3 is negative 21. H to the first times h to the second is h to the third. Negative 7 times negative 8 is positive 56. H times h is h to the second. Negative 7 times negative 1 is positive 7. H to the first is h. So there we have it. Eventually, you'll be able to do this without this middle step right here. You should be able to just distribute and figure out your answer. I'll do that in this third problem here. I'm going to multiply all the way through without writing out the middle steps. So I'm going to have negative 2 times positive 3, which is negative 6. G to the second times g to the third is g to the fifth, because we have the exponents. Negative 2 times negative 6 is negative 12. G to the second times g to the first is g to the third. Negative 2 times negative 5 is positive 10. And there are no other g's, so g to the second. Eventually, you should be able to do this, hopefully soon, hopefully within the first couple of problems that you do. So as you can clearly see, to simplify a product of a monomial times a polynomial, you're just going to distribute that monomial all the way through the polynomial, just like you would if there was a constant out there. Now, factoring is the reverse of multiplication. The reverse of multiplying is dividing, and with polynomials, when we divide, we call that factoring. Okay, that's just the number that they use, because a lot of times you have to find factors of a specific number. To factor a polynomial, first find the greatest common factor of its terms. Greatest common factor is the largest number and the highest degree of a variable that you can take out of anything. So, I'm going to find the greatest common factor of these following terms. The first thing I need to do is I need to find the largest number that will divide evenly into 2, 10, and negative 6. The largest number that can go into 2, 10, and 6 is 2. So we know the largest number we can take out is 2. The greatest number of variables that I can take out in any one term is the lowest term. There's the lowest number of variables I see. I have an x to the fourth, an x to the second, and an x. The smallest number of variables I have is this x right here. So the greatest common factor is the largest number that divides evenly, but it's the smallest variable that I have shown, which is x. So my greatest common factor of 2x to the fourth plus 10x squared minus 6x is 2x. So there's my greatest common factor. Problem 2 here. Again, I have to find the largest number that divides into 2. Between 4, 2, and 6, which is 2. The largest number of b's I can take out, I have a b to the third, a b to the second, and a b to the first, so basically I can take out a b to the first. Because I can't take out 2 b's from a problem that only has 1 b. Or I can't say, oh, I can take out 3 b's because this middle term here, negative 2b squared, only has 2 b's. I can't take more than 1 out of it. Okay? Because this one doesn't have any more than 1, so the largest I can take out of anything is 1. Problem number 3 here. The largest number that divides evenly into 5 and 10 is 5. The greatest number of g's that I can take out is 3 of them, because it's the smallest time it occurs. It's right there. So I can take 3 g's out of g to the third. I can take 3 g's out of g to the fifth. So the greatest common factor is 5g to the third. Now, how does this work? You might say, okay, I've got the greatest common factor. Now what? Okay, now you factor it. To factor it, you basically find the greatest common factor and divide every term by the greatest common factor. So if I look at problem 1 here, 4x to the third plus 12x squared minus 16x, the largest number I can take out is a 4. The largest number of variables is just an x. So I'm essentially going to divide each part of this by 4x. Eventually you'll be able to do this almost mentally. So my greatest common factor is 4x, so I'm going to take out a 4x out of each term. 4 divides into 4 once. X to the third minus x to the first is x squared, so I have x squared. 4 divides into 12 3 times. X to the second minus x to the first becomes x. 4 divides into 16 4 times, but it's a negative because it's negative 16. This goes in 4 times. X to the first divided by x to the first, or x to the first minus 1, is just x to the 0, and anything to the 0 power is 1, so this basically cancels out with that. So that's what I'm left with after I took out the 4x. So the 4x has to go on the outside. Essentially, this is what needs to happen. Once you've factored something out, if I was to multiply this back, I better get back to my original problem. So if I multiplied this, I would get 4x to the third plus 12x squared minus 16x, which is exactly what I have here. Because they are reverses of each other, inverses of each other. One undoes the other. If we look at problem number 2, the greatest number I can take out of there is a 4, because 4 divides evenly into 8, and 4 divides evenly into 12, so I'm going to say 4. Largest number of x's, x. If I divide everything by 4x, 4 goes into 8 twice. X to the 2 minus 1 is x. 4 goes into 12 3 times. And the 2 x's cancel out. So there you have it. 4x parentheses 2x minus 3. Last problem here. Greatest common factor between 6, 12, and 24. Largest number that divides into those? 6. Largest number of m's I can take out? M. So if I divide everything by 6m, I'm left with, this 6 cancels this 6, m to the 3 minus 1 is m squared, because this becomes a 1. You can put it in there or you can leave it out. It's an implied 1. 6 goes into 12 twice, so that's minus 2. M to the 2 minus 1 is m. 6 goes into 24 4 times, so minus 4, and the m's cancel out. So we have 6m parentheses m squared minus 2m minus 4. As you can see, factoring and multiplying are inverses, because if I was to multiply this back together, 6m times 1m squared is 6m to the third. 6m times negative 2m is negative 12m squared. And 6m times negative 4 is negative 24m. And if I multiplied it back together, I got exactly what I started with. That's how you can double check to make sure you've done it right. This is factoring. This is multiplying. They are inverses of each other. And that's multiplying and factoring.